In this tutorial, we are going to discuss briefly on what trigonometry is and just to have an introduction or basics on trigonometry. So from the word itself, trigonometry, you'd understand that we're going to be dealing with triangles and of course measurements of these triangles and angles that are involved in these triangles. So to start with, I would want to go into stating, that there are different angles. Let's say we know the 90 degrees angle, the 180 degrees. These are just stating basic angles. Even a degree, like a degree of one, that's an angle. So anything that is raised at a certain height would make an angle, and that would be a degree. Now, firstly, I want us to understand how we do the conversion between what we call degrees and what we call radians. So now, so the basic thing that you just have to know here is that, okay, you just have to know that pi is equal to what? Is equal to 180 degrees. Pi is equal to 180 degrees. So this means that a radian, or yes, a radian. So 1 radian, attributing it to be equal to 180 what? 180 degrees over what? Over pi. So we'll use kind of this conversion here. And then 1 degree on the other side, it means a degree is just going to be the flip of this, which is pi over what? Over 180. And this is going to be essential in what we're going to be looking at. So we have to understand how we convert between radians and degrees, because some questions, yes, will be required to solve in degrees, others will be required to solve in radians. So using this, we will answer this part uh, of our discussion. And we have this table here, and on the left side you have degrees, and on the right side you have radians. And so we are to fill up and complete this table. So now they're telling us 30 degrees, we must write that in what? In radians. So how do we do that? So remember we said pi is equal to what? To 180 uh, degrees. So now you have degrees here, then you have what? You have radians there, as we are saying. So 30 degrees. So what is 30 degrees? So if I say 30 degrees is equal to, I don't know, 30 degrees is equal to what? To x. And I cross multiply this, then I'll have 180 degrees x, then equal to 30 degrees pi. Then I divide this by 180 degrees here, then I divide that by 180 what? Degrees. So what will that give me? So the 30 can divide into 180, that is going to be 6 times. So 30 goes into what? 186 times. So this and this here will go. Then here on this side, I just remain with x. Then I'll have pi on top. Then I'll have what? 6 down. So the degrees cancel out. So this is what I get in radians. So 30 degrees is just pi over 1 pi over 6. I mean pi over 6. Then I have this other one here. Okay, so the other one is then telling me to convert this into what? Into radians. To convert this, I mean into degrees. So I have pi over 4. Then I have to convert the pi over 4 into what? Into radians. Into degrees, I mean. So to do this, it's easy just to say, okay, the flip-flop, which was just pi over what? 180 degrees here. And you see that here, this pi and that pi will divide. Then I have the 4 dividing into what? Into 180 there. And how many times does that go into that? And that will be 45. So this divides into there 45 times. So that is 45 degrees. So you have that there. Now, so here, right, this here is going to be my 45 degrees. So remember, when you're converting between, when you're going from degrees to radians, just remember pi over 180 then I multiply over 180 degrees, then multiply this by whatever you're going to, by whatever what angle you've been given in degrees. So the way we had the 30 here, and this divides there, then you have the pi over 6. But then if you're going from radians to degrees, is you want to multiply whatever you have in radians by 180 degrees over what? Over pi, and that will give you your answer. So let's do the one which follows. So you have 60 there. We have 60 degrees, and how do we convert that there? So your 60 degrees means, since I have it in degrees, it means I'm going to multiply by pi, then I divide by 180 degrees, like that. Then I divide this into that, and that goes into there. So what do I get? 60 goes into 180, that is 3 times. So I have pi over what? Over 3. So pi over 3. So this here will be my pi over 3. Then converting this other one, converting the pi over 2 going to degrees. So I have pi over 2 going to degrees, meaning I have to multiply this by 180 degrees, then divided by pi. So this and this goes, then the 2 divided into the 180 just gives me a 90 degrees. So this here is going to be 90 degrees. Then of course, the next one, 180. So you have 180, you have degrees there, then you're multiplying by pi again over 180 degrees. And this here just gives you what? Pi. So I remain with pi. Then the other one here, so you see you do the same procedure, you get that this will be a 270 degrees, and that there will just give you 2 pi. So this is how you convert between radians and degrees. All right, so next we want us to just look at okay, so we have this part here, and I want us to talk of the trig ratios. So let's talk of what we call trig ratios. So let me highlight this first of all. Okay, so how do I go about these trig ratios? All right, so okay, so I have trig. So how do I go about these trig ratios? So when we have the trig ratios, there's something that really helps us to work around these trig ratios. So yeah, and the word is SOHCAH. So the word is SOHCAH. SOHCAH. So now when I'm dealing with my trig ratios, so what I have is that I'm dealing with, so the S is for sine, which is written as sine, the shortcut. Then I have the C here, the C is for cosine. So C is for cosine, which is short, we write it as cos. Then that there is for tangent. For tangent, then in short, we just write it as tan. We write it as tan like that. So these are the trig ratios which will be introduced to, and I'm sure you have come across them. But then, what does this word help us to do? So this help us, since we're dealing with trigonometry, and we know that it involves triangles, and mostly we work with a triangle, a right angle triangle, which will have here a 90 degree, and you have some other angles that are there. And these all angles here adding up to 180 degrees. So now this here is going to help us to come up with what? With a ratio. It's a trig ratio. So the trig ratio is now for sine. So what we say is, if I have this angle here and I name this angle theta like this, and I'm standing at this point. So if I'm standing at this point here, like this is where I'm standing, then now I am taught to find sine of what? Of theta. Sine of theta. So sine is given by, opposite over what? Over adjacent. So now if I'm standing here and this is my angle at which I am, which is theta. So sine is opposite. So opposite of this angle is actually this side here. So this there is going to be my what? My opposite. Then now, hypotenuse. The hypotenuse is always the opposite of the 90 degrees or the longest side. So my 90 is here. So this here is going to be my hypotenuse. Then the adjacent side, that is where the angle and the 90-degree lie on the same line. So this is the adjacent. So it's going to be useful when it comes to the other trig ratios. So for sine, it only involves the opposite and the hypotenuse. So that is opposite over what? Over the hypotenuse. Then we see the next one is cos. And cos, if I'm standing here still, cos is just the adjacent divided by the hypotenuse. So you see that the first letter that comes after that sign or that trig ratio is what is in your numerator, and the one that follows is what is in your denominator. So you have cos, and here cos we have the adjacent divided by the what? The hypotenuse. So the adjacent is here. That is where my angle is straight with what? The 90 degrees or lie on the same line. So that is cos theta is going to be adjacent divided by the hypotenuse. Adjacent divided by the hypotenuse. Then the other one which we have is what is tan. And tan theta is just going to be what? The tan is opposite over hypotenuse. So opposite over the hypotenuse. So this here are my what? Are my trig ratios. Now, apart from these trig ratios, we can further introduce other trig ratios. So we can further introduce other trig ratios, and that is the first one is sec. So sec theta. So sec theta is just the opposite of what? Of this one which we have as cos. So sec theta is the hypotenuse over what? Over the adjacent. The hypotenuse over the adjacent. So if you look at the cosine here, it's adjacent over hypotenuse. The sec is hypotenuse over what? Over adjacent. So you'd see that this is sec theta is just the what? The inverse of the cos, or when we say 1 over cos theta, this here gives us what? The sec theta. Because when we divide, so 1 over cos theta, and what is cos theta? Cos theta is just going to, is adjacent over what? Over hypotenuse. And this here is just going to give us the hypotenuse over what? Over the adjacent, which is our what? Our sec theta. So we've introduced this one, sec theta, which is the hypotenuse over adjacent. Then another one which we can introduce here is cosecant. Cosecant. So cosecant is given by, so 1 over what? Over sine. So I'm saying 1 over sine theta, which is just the flip of this. The flip of this. So that means it will be hypotenuse over the opposite. This is cosecant theta. Then you have the last one, which is cotangent. Cotangent. And the cotangent is given by, okay, which is 1 over tan theta. And of course, this here is just, so the opposite of this. Okay, so here we say that is opposite over hypotenuse. So it will be hypotenuse over what? Over the opposite. Now, you notice that tan theta, you must know that tan theta can be written as, so tan theta can be written as sine theta over what? Over cos theta. And this is easy because, this is right because if you observe, so this is your opposite, why it can be written like this. So what is my opposite? My opposite, I mean, what is my sine theta? My sine theta is just opposite over the what? The hypotenuse. Then I'm dividing this by what? By my cos, which is adjacent over what? The hypotenuse. And you see that this here is just the same as saying opposite over hypotenuse, like this, then divided by hypotenuse here, like that. the hypotenuse, okay, over the adjacent, hypotenuse over adjacent, and this divides and you remain with what? The opposite over the adjacent. So this here gives you what? This part, which is the TOA. So tan theta can be written as sine theta over what? Cos theta. So if that can be written like that, it also means that the cotangent theta can also be written. So cot theta can also be written then as the flip of this, which is cos theta over sine theta, like that. Okay, so now after doing this, let us look at an example. Let us look at an example on how we can find this. All right, so in our example, we want to find the sine and the cosine of the cosine and the tan of whatever we will be given. So you have, let's say we have a triangle given like this. It's a 90 degrees. It's a right angle triangle with the side here to be 12 and that side there to be what? To be 5. Then you have an angle theta here. And I'm told to find sine of theta, cosine of theta, and tan of what? Of theta. How do I find that? So first of all, I'm standing here. So my sine theta is, so sine, remember, SOH CAH TOA, it's opposite. So what's the opposite of this angle is 12 there. So opposite over what? The hypotenuse. So hypotenuse, my hypotenuse is actually the opposite of the 90 degrees and I do not have. So I need to get that. But how do I get that hypotenuse? I can get that by what? By Pythagoras' theorem, knowing that if I have c squared is actually going to be equal to a squared plus b squared. So if you have two adjacent sides, you can square them and then add them, and that will give you the longer side, which is the what? The hypotenuse. So if I square 12, so I can square 12, add it plus what? Plus 5. I square this, and this will give me my what? My hypotenuse. So now, here, what do I get? I get 144 when I square, then here I get 25. Okay, so now what do I get when I add these two? What do I get when I add those two? So, okay, so 144 plus 25 gives me 169. So I get 169 here. But then this is c squared, but I only want c. So meaning I take the root of both sides. So remember c squared. So I get this such that I have c to be equal to, and that will be 13. So it means this longer side here is what? Is 13. So sine theta over sine theta is just the opposite. Then now I found my hypotenuse, which is 13, and I'll get that there. So this is my sine over what? Theta. Then I have now to find the other ones, which is cos theta. So cos theta is just going to be adjacent. My adjacent with the angle is 5. Then my adjacent over hypotenuse, which is what? The 13 I found. Then the last one, which is tan theta, is just going to be the opposite, which is 12 over the adjacent, which is 5, like that. All right, so this is how we get what we were finding or what we were looking for. Okay, so now let's say we are given another question. Okay, let's say we have this question and the question is of the form. Let's say we have the question sine theta, and they have given us that this is actually equal to what? To 8 over what? Over 17. Then they're telling us to find the value of what? To find the value of the other ones. So we should find the value of cosine and the value of what? Of sine. But this should be in between what? 0 degrees. So they've given us a restriction, 0 degrees. So theta should be in between 0 degrees and what? And 90 degrees. So what does this tell me? So now, okay, if I have my X or Y plane like this, so now we have what we call the quadrants. So you have this one being the first quadrant, the second quadrant and you have the third and the fourth quadrant. So from here, we measure angles from the positive x-axis going towards the anti-clockwise direction. So we're going towards the negative direction. We're going anti-clockwise. So if this is 0 degrees here, when I move this direction, this angle here, when it's straight, that is a 90 degrees. Here, that is 180 degrees. There, that is 270 degrees. And there again, I'll have what? 360. So 0 or 360. So now, or if I'm writing it in radians, of course, 0 here will remain 0. But this here can, the 360 will be what? 2 pi. The 90 degrees here is just going to be pi over 2. Then I have the 180 is going to be pi. Then I have this here will be 3 pi over 2, if that is in radians. Now, what am I to find here? So now, what I'm to find, they're telling me I should find the other ones. I should find cosine, and I should find tan theta. So, but it should be in between 0 and 90 degrees. So this tells me that my angle is actually in the first part here. So it's in the first part, here. And we see here in the first part, meaning my angle is going to be somewhere there, like that. That's where my theta is. Let's say my theta is here, and I have a 90 degrees there. Then they're telling me, so here, I know that sine is actually opposite over what? Hypotenuse. So it means my opposite is here, 8, and my hypotenuse is what? Actually 17. Then they're telling me to find the others. So the others now I have to find cosine and what? And tan of what? Of theta. So what is cos theta? Cos theta, I know is what? Is adjacent over hypotenuse. Now, do I have my adjacent? I do not have. So it means I first have to find my what? My adjacent. And I can easily find my adjacent. Okay, I can easily find my adjacent by, of course, Pythagoras' theorem, where if I have the shorter side, so as we said, it's c squared equal to a squared plus b squared. Now I'm finding one of these shorter sides. Let's call it a. So it's going to be me subtracting c squared minus what? The b squared. So I square my 17. So 17 squared, then I'm saying minus what? Minus the 8 squared. What does this give me? So 17 by 17 gives me 289. Then that there gives me 64. So I can subtract that and I just get 2, 2, 5. Yes, 225, like that. So that's what I get when I subtract those two. Now, so what is the root of that 220 what? 225. What is the root of it? So, okay, so what is the root of the 225 there? So just a moment, I use my calculator. So root of, okay, so root of 25. So here, I'll just get a what? I'll just get a 15. So if I put this in the root, this just gives me what? A 15. So means that this shorter side here, or this adjacent side, I mean, is going to be what? Gonna be 15. So finding now the other ones, so I continue with what I was finding, which is the cosine, cos theta, and adjacent. I found my adjacent side, and my adjacent is 15. My hypotenuse is 17. So I have this here. And tan, so tan theta is just going to be so TOA, so opposite over adjacent. So my opposite is 8 and my adjacent is 15. So this here is what I am required to find. All right, now let's go into what we call special angles. So for special angles, you have angles like 30 degrees. You have angles like, so we have angles like 30 degrees. We have angles like 60 degrees, 45 degrees. These are known as special angles because they come from special triangles that have some good findings. So now let's start with the 30 and the 60 degrees. What do we want to get from there? We can actually get our trig ratios faster from those, and this is how we do that. So if we have a triangle, let's say we have an equilateral triangle, and that equilateral triangle, so by an equilateral triangle, we understand that all the sides are equal. So let's say I have this triangle here, that's all sides equal. Well, mine is not really drawn to scale, but I'm sure you get the point. Then I split this triangle here, and because all the triangles because this is an equilateral triangle, and triangles are to add up to 180, it means that this here is 60-degree angle, and there is also a 60-degree angle, and there is 60-degree angle. But here I write it as, since I've split it into two, so I've split it into what? There's a 30-degree, and also there a 30-degree angle. So I have this here. And let's say the sides, since the sides are all equal, so this side here is 2, that side there is 2. It also means this side is 2, but I've split it into what? Into half. So I'll get a 1 there, get a 1 there. Okay, working out my Pythagoras theorem, I'll just get this here, because when I add square, add this, I'm just going to get what? There's a root of what? 3 there. So that's going to be my root of what? Of 3 there. Okay, so now getting this here, how do we then use this? How is this so useful? So this is so useful. So when you look at it, you have 30 degrees, and you have what? You have 60 degrees here. So let's say I start with the angle 30. Then I'm told to sine 30 degrees. So what is sine 30 degrees? So sine 30 degrees is going to be what? Sine is opposite over hypotenuse. So my opposite, what's the opposite to this angle here, is actually this side where there's 1. So this here is my opposite. Then my hypotenuse is opposite of the 90 degrees, which is in this case 2. So this here is just going to give me opposite over my what? My hypotenuse. So it's going to be 1 over what? Over 2. So that is sine 30. So I can do the same. Cos 30 degrees, cos 30 is the adjacent over hypotenuse. So my adjacent here is root 3, like that. Then my hypotenuse is what? Is 2. So this is what I get. Then I have the last one, which is tan 30 degrees. So tan 30, your tan is so TOA, that's opposite, which is 1 here. Opposite, you have 1 over the adjacent side, which is what? Root 3. You have root 3 there. So now root 3, this can be written also, if I rationalize, I'll just have this being equal to root 3 over what? Over 3, like that. So this is my 30 degrees. Then with my 60 degrees, I can do the same, sine 60 degrees. So where the sine here, so what is my opposite? My opposite is this side where there is the same root 3. So that's root 3, my opposite, then divided by my hypotenuse. So my hypotenuse, the opposite of what? Of the 90 degrees, which is 2. Always the hypotenuse is the opposite of the 90 degrees. Then I have cos 60 degrees. So cos 60 is just the adjacent over hypotenuse. So adjacent is 1, and then the hypotenuse is what? Is 2. So I get this. Then tan 60 degrees. So tan is going to be, so TOA, that is my opposite, TOA, which is root 3, over my adjacent, which is 1. So this just gives you root 3, like that. So this is what I get out of this special angle or special triangle, this special triangle with this angle of 30 and the 30 and the 60. All right, so now let me consider a triangle with a what? With a 45 degrees. So triangle with a 45 degrees. Okay, so triangle with a 45 degrees, you have this here. Let's say I have this as a 90 degrees, and I have this angle to be 45, and I also have that angle as a 45 degrees. This side being 1, that side being 1, then I'll have that this will just give me root what? Root 2. So now I can do the same here. So I can find sine 45 degrees. So sine 45 degrees, sine 45 degrees is just, as you can see there, opposite. So whatever, let me say I'm standing here, opposite is going to be here. So that's my opposite, that's 1. Then I have my adjacent. So opposite, I mean over hypotenuse. The hypotenuse is root 3. So root 2, I mean root 2. And I can rationalize this. And this will just give me root 2 over what? Over 2. And I say the same thing, cos 45 degrees. Cos is going to be adjacent, which is 1, over the what? Over the hypotenuse, which is root 2. And this again still gives me the same thing, root 2 over what? Over 2. Then tan 45 degrees is just the adjacent over, so TOA, I mean the opposite, which is 1 over the adjacent. And this is just going to be 1 over 1, and this gives me 1. So this here is what I get. So these are the special results which are what? Which I have. But then I can also consider for what? For other triangles, for other angles, I mean, for other angles like the one, other angles like 90 degrees or 0 degrees, 180, 170. What do I get when I have that? So it's going to be easy when you look at the graphs. So we have what we call the sine graph, and the sine graph, I'll draw it. So it looks something like this. Okay, so where this is 1 and that's -1 and that's 0. Okay, so now it's going, starts from here, it rises, then goes down, cuts the graph, then goes up to that point. So it starts at 0 degrees. Then here at this point, that's a 90 degrees. At this point where it cuts, let me use white, that's a 180. So that's a 180 degrees, and that part there is the 270 degrees, and you have a 360 degrees. So from here, it's easy to see what our sine is going to be. So sine 0. So sine 0, the graph is just here. So meaning sine 0 degrees is just going to be 0. Then sine 90 degrees is here. So sine 90 is going to be 1. Sine 180 will give me 0 because it's here. Then 170 here, as you can see, it's plotted here. So this here should correspond with this part, which should be the -1. So sine 270 degrees is just going to be -1. 360 degrees, that's going to be what? To be 0. So this is what we get from the what? From the sine graph. Now, we also have the cosine graph. So the cosine graph starts from here. So you have 1, and then you have -1. So the cosine graph starts from the top, and it falls like that, cuts the graph, and it goes like that. So what you have here is the 0. So here that's at 0, since this is 0. Then here you have where it cuts next is 90 degrees. There where it goes down, that's 180 degrees. Here where it passes through, then that's the 270. Then here where it comes to end, at end point there, is 360 degrees. So what does that tell you? So this is a cosine graph, the standard one. So cos 0 is what? Is 1, because 0 degrees is 1. As you can see here at 0, this is 1. Because 90 cos 90 degrees is 0. Then you have cos 180 degrees to be what? To be negative 1. Then you have cos 270 degrees to be what? 0. And cos 360 degrees to be equal to 1. So these are what the values that you get. Okay, another thing to see from here is we could draw the tan graph, but then it is hard, or the tan graph itself, you see that even when it comes to being asked questions, you're not asked to sketch or find the tan graph, because its points, some of it are what are undefined and is not as smooth of a curves as that of the sine and the cosine. But you can check that, not cover this in our video, but you can check that and see that the tan of 0 degrees on that graph is 0, and you have tan of what? Of 90 degrees. You see that it is dotted at this point, and that means that it's what? Just undefined. It's undefined at that point. Then you have tan 180 degrees, and that is 0. Tan of 270, you see it's dotted again here, so that's undefined again here, meaning we do not know what value that is there. Then you have tan 360 degrees, and that gives you what? That gives you 0. Okay, so those are some of the angles which you find, or which you'll be required to know. Okay, now from here we want to just briefly answer a few questions. So suppose we are given sine. Let's say they say we have sine x, and sine x is equal to what? To 3 uh, over what? Over 5. Then they're telling us that x is just a member of this is pi over 2, so they're using radians, then pi over what? Over x. So x is in this range here. So we're being given a range, we're being guided that it's actually between what? Pi over 2, and pi over 2 is 90 degrees, and pi is just what? Is 180 degrees. So it's in between. So in short, x is in between 90 degrees and 180 degrees. So that's where x lies. Okay, now there's something that we forgot to mention, or we haven't mentioned yet, which is on the quadrants. So on the quadrants, you notice that here in the first quadrants, all of them, everything, the sine, cosine, and the tangent are all positive. On the next one that follows, only sine is what is positive, then the rest are negative. The one that follows, tan is the only one which is what? Which is positive, the rest are negative. Then the last one, you have only cos to be positive, and the rest are what? Are negative. So the short acronym to be all students take calculus. So you see that here, every one of them are positive. So here you have O to be positive. So I'll just write say O. Here you only have sine to be what? To be positive, the rest are negative. Here you have tan to be positive, the rest are negative. Here cos is positive. And you notice even as we will do this example, why it's so. All right, so we have this which we have been given. Then now they're telling us we must what? Let's find the other. We should find the cos, and we should find cos of x, and we should find tan x. So being given that it's in between 80, so it's been, in between 90 and what? And 180 degrees. What does that tell us? In between 90 and 180 degrees. So if I check that with my graph, it means here, if I am moving, this here is my 0, that's my pi over 2, and that's my pi. So it's in between, it's here. So what does that mean? It lies in the second what? In the second quadrant. So it lies in the second quadrant. So I have my triangle here like that. So my theta, I have my theta here. And then what is sine? Sine is opposite over what? Over the adjacent. So the opposite here, this side is 3. The adjacent, I mean, the opposite is 3, then the hypotenuse is what? Is 5. So this side, which is opposite to the 90, is going to be 5. Now they're telling us to find cos x and what? And to find tan x. So it means we have to find this other side here. And how do we do that? We know if we just square 25, we square the 5, we get 25. Square 3, we get the what? We get 9. And when we subtract this here, we get what? We get 16. And root of 16 gives us what? 4. So this side here has to be 4. So that side there is going to be, that side there is going to be 4. Okay. So now here, so I need to now find tan x. So tan x is tan x is just adjacent over what? Over the hypotenuse. So adjacent over the hypotenuse. So my adjacent is 4 and my hypotenuse is what? Is 5. So adjacent is 4, hypotenuse is 5. So one thing you must notice is that always the hypotenuse is going to be positive. But when you look at this here, we are moving actually in the negative what? Direction, this side. So it means that this 4 here is actually negative. So your adjacent, which is 4, is negative. So you have -4 and your hypotenuse is what? Is 5. So this gives you that cos x is going to be equal to what? -4 over what? Over 5. So this fraction here is negative. And remember we said all here, students take chemistry or take calculus. So you see that what we had said that in the second quadrant, only sine is what? Is positive. And we see that here on cos, we obtain something that is what? That is negative. So that proves that. Or you would notice that even if you had put here to say 4 over 5, and this here would bring you back to say this has to be negative because only sine can be what? Can be positive. Now to find tan, we do the same thing, to which is our opposite over what? Over adjacent. So opposite here, this angle is 3. So tan x is going to be 3 over the adjacent is what? Is 4. So here this is positive because it's going in the positive direction, and that there is negative because it's going in the negative direction. So this here will have a negative sign. So that is what we get. And this is how we would find those other parts. Now, let us look at something kind of different where we have angles, or we have a question involving angles, and we are taught to find the value of the sine, or to find the value of the cosine with this angle. If it's not a special angle, let's say we have an angle, we have the angle cos 240 degrees. We are taught to find cos 240 degrees, but this is not any of the special angles we have looked at. So how do we find this angle? So we should remember yet again what we have discussed to say, okay, the quadrants. So we said our angles are measured from the positive x-axis going towards the negative, or going in the anti-clockwise direction. So these 240. So if I see this is 0 degrees, that's 90 degrees, that's 180 degrees, and that is what? 270 degrees, and of course 360 here. Now this tells me that my angle 240 is actually in between 180 and what? And 70 degrees. So what does that mean? It means that it's in the third quadrant. So in the third quadrant, I will move starting from there, where I start here, going up to the third quadrant. So I'll move like that. So meaning my angle, I'll have it somewhere out here. That is the angle to what? 240 degrees. So now here, the way we find this cos 240 is we find a reference angle. So the reference angle is this angle which just lies here in the third quadrant. Not the whole angle, but only this part of the angle, here, which lies in the third quadrant. So now what is that angle here? I know that from here to there, that is 180 degrees. Then I know that the whole thing from here up to that is 240. So it means when I subtract the 240 degrees minus 180 degrees, it gives me this angle here. And that here just gives me 60 degrees. So it gives me that angle there, which is 60 degrees. And I can write that as cos 240 degrees is equal to what? So the 60 degrees tells me is this angle here. But yet again, I should remember the quadrant. All students take coffee. So here we're looking at cos. Cos in the third quadrant is actually negative. So it means I'm going to have negative I'm going to have a negative in my cos. So I can write this as negative cos 60 degrees. And this is going to give me, okay, 60, I know that is half. Then the negative there, I get -1 over 2. So this is what I get. All right, I can also evaluate a similar question. Now, this is tan, and how do I find my tan? So let's say I have tan 120 degrees, and they tell me to find this angle. It's not any of the angles we've looked at from the triangles or from the graphs. So how do I do this? So how do I do this? I find again, the reference angle. So you have this here, and this angle is 120. So it means that it's in between In between 90 degrees and 90 degrees and of course 180, or it's in between 0 and 180. So we're starting from 0 going there 90, and you have 270 there. So from 0 until we measure the 180. So it's in between 90 and 180. It means that it lies in the second quadrant. So I'll move from here up to that way. So my angle is somewhere there. So that is my 120 degrees. So that's my 120 degrees. Now, how do I find? I need to find the reference angle, and my reference angle is actually this one here. So I know if I subtract 180 from 120, I get that reference angle. So 180 degrees minus 120 degrees gives me my reference angle, which is just, again, if you can see here, it's going to be 60. And here again, I remember my quadrant. All students take calculus. So here it's again in the second quadrant, tan, which I'm looking for, is actually negative. So it means here I'm going to have a negative value there, which is going to be there. So my tan 120 degrees is just going to be the negative value. Then I have tan, my reference angle, which is 60 degrees. Now tan 60, I know that is root of 3. So meaning I'll just get root of 3 here. And that's how I find my angle. All right, if you're new to this channel, remember to hit the subscribe button to get more notifications, and remember to share and like this YouTube channel. This is where we end with our brief introduction to trigonometry.